Create a table of values for the quadratic function centered around the vertex, then graph the function. Right now, our function is in standard form, and we kind of need to convert it a little bit towards vertex form. So we're going to calculate the h value of our vertex by using some of the numbers that we have here. There's a very small formula that's pretty nice that works with this. Since this is in standard form, normally standard form looks like ax squared plus bx plus c. So we have the a, b, and c numbers that we need to focus on. If I want to calculate the h value of my vertex for vertex form, I have a little formula for that. It goes h equals negative b over 2a. Whatever my b number is, my a number is, I'm going to plug those into this formula, clean it up, and I can get the h value so I can start making my table. So let's look at the ABC values that we have on this particular function. If I think about it, in front of this x squared would be a 1x squared. So that means my a is going to be 1. B is going to be, we got a minus, so we'll say negative 4. C doesn't really matter, but we can go ahead and talk about it. C is going to be minus 7. Technically, C is actually a y-intercept. If you wanted to, you could put your C number on the graph immediately, and that would be totally fine. Okay, we need to calculate our h value. I have b as negative 4. Let me do a different color to help with this a little bit. My formula says negative b. So when I plug this in, I need to be careful. That negative comes from the formula. So I would suggest writing your formula like this, where you have blank spots. Let's put the b number in the top blank spot, and the a number goes in the bottom blank spot. If I read that, it says opposite of negative 4 divided by 2 times 1. So I'll be like positive 4 over 2, which means that would all clean up to be 2. So I'm going to write my table. Usually I'll put my h numbers in orange. It's like Halloween. I'm going to make an xy table with 2 in the middle of it. So let's put that orange 2 in the middle. And I need to figure out numbers that are before and after 2, since 2 is in the middle. So we'll go 1 and 0, and then 3 and 4. Just like we always do, I got a bunch of input values. I will use my original function like a formula and plug in those numbers anywhere that I had an x. So I'm going to set up like a little template, if you will. 1x squared minus 4x minus 7. I need to get at least 3 of these so I can show the symmetry in my table. So let me fill these out. Minus 4 minus 7. Plugging in the numbers that are in our input over here. So I have zeros in this first one. Got ones in this second one. And then I'm going to plug in my fancy 2 in that third one. That way I can just calculate all 3 and get it over with. So grab a calculator. Let's type exactly like we wrote. We'll just get all 3 answers really fast. Parentheses, 0 squared minus 4 times 0 minus 7. There's one answer. Next one, 1 squared minus 4 times 1 minus 7. And the third answer, 2 squared. This is the worst part. Minus 7. So I got negative 7, negative 10, negative 11. Whew. Let's put all these in here. Negative 7, negative 10, negative 11. And if I use the symmetry part of quadratic functions, then I can reflect those. Negative 10, negative 7. All right. Let's plot these ordered pairs on our graph. Let me get rid of my graphing calculator real quick. All right, 0, negative 7. Hey, I accidentally already graphed that because it's a y-intercept. That comes from the c value. Positive 1, negative 10. Oh man, I did not have a big enough coordinate grid for this. Embarrassing. My vertex is down at 11. I'm taking a wild guess on here. Please use a coordinate grid that's big enough. And then our symmetry takes over, and I can get my U shape to come off of this. I apologize for not having a graph big enough for this. Make your smiley face and extend your smiley face through the eyeballs for a nice parabola shape. This question is done.